So let's do that. It might have been easier. It might have been easier to do this problem with the inequalities, but I wanted to show you the derivative being used at least once. So for part 2, I want to show that the limit as n goes to infinity of the sequence, right, which was n squared over n cubed plus 1, that is 0. So I want to show that that's true. So is it? That's infinity over infinity, right? So L'Hopital? So let's do L'Hopital. Derivative of the top, 2n. Derivative of the bottom, 3n squared. Now cancel an n. And you just have limit, this was after L'Hopital, limit n goes to infinity. All that's left is a 2 on top and a 3n on the bottom, and that obviously goes to 0, right? Done. It converges. We're going to do some definitions now. A couple of definitions to put up here. First, we're going to start with what's called absolute convergence. So let me write the definition. A series sum a sub n. So this could be alternating. It could be just a regular series. Just here we go. We got a series, all right? A series is said to be absolutely convergent if the absolute value of this series converges. Careful. The series by itself need not converge. All right. Let's do an example first, then we'll talk about this definition, because this definition can be confusing the first time you see it. So your first example is this. I'm going to squeeze it right in here. Let's take the series sum n equals 1 to infinity of -1 to the n plus 1 times 1 over n. You'll recognize this as being 1 minus a half plus a third minus a fourth plus a fifth minus a sixth plus dot, dot, dot. All right, we did that a little while ago. What did we say that did? Remember what we said this does? This converged. All right, we showed this converged. We showed it converged using the alternating series test, right? That means if you start adding these things up forever, it's going to go to a number. Now, this is a series, right? This is a series. Let's take a look at the absolute value of this series. So I'm going to put here, but sum equals n, sum n equals 1 to infinity of the absolute value So if I take the absolute value of that series, what happens? Yeah, that negative 1 to the n no longer matters because I'm always going to take the absolute value of it, and it's always going to spit out a 1, right? So that's basically dead. All you have is the 1 over n. So this just becomes 1 over n. And what does that series do? This diverges. Right? Is this series right here absolutely convergent? Read the definition. This is the original series right here. I'm asking you to look at this and tell me, is this absolutely convergent? It is not. The reason why it's not is because to be absolutely convergent means that when you take the absolute value of the series, right, that converges. And when I take the absolute value of this, that actually diverges. I would need this to converge in order to say that it's absolutely convergent. Understand that?
So you're just taking the absolute value of the base, like regardless of whatever power it's raised to?
The absolute value of the...
Of the negative 1, and that's why it's going away?
That's why this, yeah, because when you do this absolute value, you can actually split it up into absolute value of this times the absolute value of that. And the absolute value of negative 1 to any power is just 1. All right. So that is not absolutely convergent, right? Let me take another one. How about this one? I'm going to squeeze this one in here real quick. Take the series sum n equals 1 to infinity of negative, I'll write it a little different so you can see some different notation, negative 1 to the n over n squared. What type of series is that? Alternating series, right? So I could run the alternating series test on this. I'm not going to do it because of time. If you did the alternating series test, you would be able to show that this converges. All right? If you take the absolute value, okay, take the absolute value of that, then that negative 1 doesn't matter anymore, right? And that just becomes a 1 over n squared. What type of series is this? P series. This is a P series with P being 2, and it will converge. This one also converges. All right? Is this series right here absolutely convergent? Yes. Because the absolute value of this converges. Yes? Okay. Give you one more, and then we're going to talk more about this definition because it's weird. How about this? Wonder if the book does this. No. Oh, I guess that's good. The thing that's dangerous about this is that most people, when you see the word absolutely or absolute, you think like all the time, like it's just like always convergent. And when I showed you that series before, the one that was like the harmonic, right? That series converged. Its absolute value diverged, right? Yes? So, but this was not absolutely convergent. Right? So how am I know what I'm trying to say, but it's not coming out. Could we come up with a series that this would converge, but this would diverge? What do you think? Do you think we could come up with something where the absolute value of it converged, but this series by itself diverged? I gave you an example a minute ago where this converged, right? But this diverged. Is it possible to go the other way around? This converges without that converging. You think it would be possible, right? I mean, what did I write?
It says need not converge.
That's right. Okay, need not. Yeah, but that's okay. I think this is what gets so tricky about this. Let me give you this example. I need to come up with one real quick. No. I don't think this is going to be a good illustration. What does this series do? It does. It alternates, right? It's just like -1 + 1, -1 + 1, -1 + 1. Isn't that what this is? All right. Let's do the nth term test. Right? Nth term test. Let's just try it. What's the limit as n goes to infinity of -1 to the n? It's going back and forth between 1 and -1, right? So is it going to 0? Does this go to 0? No. And what does the nth term test tell us? If it doesn't go to 0, it diverges. This series diverges, right? Okay. If we take the absolute value of this series, this is just sum n equals 1 to infinity of just 1, right? What is that doing? That diverges also, right? This diverges. Why does it diverge? It's just 1 + 1 + 1 + 1 + 1, right? What I'm trying to get at here, and again, I don't think this was a good illustration. When I put note that the original series need not converge, is that to run your absolute convergence test, you don't have to start with a convergent series, right? You don't have to. You can start with any series. If the absolute value converges, then you say it's absolutely convergent. All you need to happen to say absolute convergence is that this happens, regardless of what happens to this. That's what I was trying to say. Now, there's a theorem, and that's the next thing I want to put up on the board. A theorem that says this. And this is the last on your table of things. I'm actually going to call this the absolute value theorem, because it doesn't have a name in the book, but I'm talking about the last one on your sheet. Okay? It says, if the absolute value of a series converges, then the the series by itself converges. It's a must. So if you take the absolute value of a series and it converges, then you can guarantee me that the series itself had to converge. Make sense? So absolute convergence implies convergence. Absolute convergence implies convergence. And we can use that for something like this. Take a look here. Nth term test. Start out with nth term. Bounded, right? Bounded on top, over infinity goes to 0. Inconclusive. Not geometric, not harmonic, not p-series, not integral. Comparison. Can I do a comparison? This one's a little tricky. As n goes to infinity, cosine of n is going to be jumping all over the place. It's going to be positive sometimes and negative sometimes. This is not going to stay positive. So I cannot use the comparison test. You all understand that? This a sub n is not always bigger than 0. Sometimes it is, sometimes it's not. Because we're going cosine, looks like this, and we're picking dots off of it, right, as we're going out to infinity. And so it's going to sometimes be positive and negative. Comparison, throw it out. Is it an alternating series? No. The reason it's not is because alternating series has to be plus, minus, plus, minus, plus, minus. This is switching between positives and negatives, but it's not always a positive then a negative, positive then a negative. It could be two positives then a negative. It's weird. You'd have to write them out to see. So you cannot use alternating series test, which means we're kind of jammed up on this one a little bit. Do you understand? But what I can do is hope for absolute convergence. So let's take the absolute value of this. If I take the absolute value of this, then it's really like I don't need to take the absolute value of the denominator because n squared is always going to be positive, right? So I started with this series. Everything I had in my arsenal of tests failed. So I just take a look at its absolute value. When I take a look at its absolute value, I say to myself, now that I can guarantee that these pieces will be positive, right? Those should be positive. Pardon? Now I can compare it. Now what would you like to compare that to? We're going to compare it to 1 over n squared. I compare that series to 1 over n squared, which is what type of series? P, this one converges, right? Because P is 2. Convergent series. Now, how do I actually set up the comparison? It's convergent, so I could either try and make these guys less than these guys, or I can do the limit comparison. Any preference? You want to try limit comparison? Yes? So I'm going to do the limit comparison. And I want to show that the limit as n goes to infinity of a sub n, which is absolute value of cosine n, over n squared over 1 over n squared. I want to show that that's a constant. Is it? What does that turn into? Limit n goes to infinity of just cosine, absolute value of cosine n. Does that approach a constant, positive constant? N is moving, right? So the absolute, look, cosine n looks like this. right? Cosine n looks like this. The absolute value of cosine n just makes all your negative parts positive, or yeah, positive. So it goes like this.